Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard 8.9C in the great state of Texas, and we are using item number 18 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this table here, and it represents an exponential function. And so we need to find the best way to rewrite this as an equation here, and they're all very similar. And so first, let's look at our reference materials. And if we do that, I want to show you that we have linear equations, we have quadratic equations, but for some reason they never give us anything about exponential equations or exponential functions. So that is knowledge we need to bring into the STAAR test on our own. So what is our standard form? Because if we can remember our standard form for exponential functions, then it's really not going to be that difficult here. So we're going to start with y equals a times b to the x power. That's it. You've just got two different numbers we're dealing with, an a and a b. The y and the x are going to stay as the y and the x. In this case, our y happens to be p of x, so we can do it like this. We can say p of x, right? That's going to be our y value. Our dependent values a times b to the x. All right, so let's start looking at what do we have for each of these. This is our initial value, or we can say our starting value. If we are dealing with money and we're talking about compound interest, right? This is our principal. So this is the amount of money that you would initially have deposited and you're going to gain interest on. All of these kind of mean the same thing, and this is the beginning. So where are we beginning here? Now, a lot of times when we deal with exponential functions, what we get is a word problem or a verbal description, and we kind of write that in there. There's not really anything in here except for this table. So where can we find our beginning or our initial or our starting value? Well, think of it as if it were a graph for a quadratic function instead. What would we be looking for? Well, we would be looking for intercepts, and we have an intercept right here, okay? So when this x equals 0 is going to be our y-intercept, and think of it whether it be a quadratic or even a linear, when you have that y-intercept, that ends up being a starting value. So our initial value is going to be 90, because we can also add to our list here a y-intercept is going to be an initial or starting value, because that's what happens when x equals 0. Because when x equals 0, 0 as an exponent just turns that number into 1, and anything times 1 is itself. So that's really what we're looking for. All right, so p of x, we can say, equals 90, and then I need b. What is b? b is my rate, okay? And so my rate is how is it changing from unit to unit. Now these are going by ones, so that's fine. So what we can do is we can take each p of x and divide it by the previous one, 90 by 270. We can do the same thing here. Equals, because we're at this rate here, constant rate that's growing exponentially here. I've got a 10 over 30. So those are all equal. So we do have this constant rate that is being affected by this exponent, right? The x is going to be our time, typically hours, days, whatever, sometimes years. What do all of those equal? Well, those are equivalent fractions, and they all equal 1/3. So that's going to be my rate, because you know that it's being divided by 3 or cut into thirds every single time, and then that is being taken to that exponent of 0, 1, or 2. So we're going to say this is our 1/3, and there we go. That is the equation we are looking for, and so our answer is going to be right here, C.